All right, here we are. Now we'll be doing sine, cosine, and tangent of degrees and of radians. And so, uh, again, I think you're very comfortable with degrees, and so I'm going to present this in degrees. But being familiar with radians is going to be just incredibly important. And so please do make sure you're practicing with radians as well as degrees. Okay. So sine, we talked a little bit about this, that if I've got my coordinate plane, my Cartesian coordinate plane, that here's a given triangle, and let's say that this is 60 degrees. Okay. If that angle right here, our reference angle, is 60 degrees, and I'm thinking in terms of SOHCAHTOA, of sine, cosine, tangent, then sine is opposite over hypotenuse. Okay. So then my opposite, yeah, that's this side over here. That's always going to give me my, um, sorry, sorry about that. That's going to always give us our y value. It's rising versus the adjacent, the cosine. Cosine equals adjacent over hypotenuse. That'll always give us our x value. And we've talked about this, but just really want to kind of get it home that we're talking about the x and the y. Now, tangent is our TOA, opposite over adjacent. And so we'll end up taking our sine, our opposite, and dividing it by our cosine, or by our x value. So here we go. Sine of 0 degrees. So if we've got our circle, sine of 0 degrees, that's right here. That is not the y value. It's not up or down at all. It's 0 degrees. The cosine there, well, it's to the right, our radius of 1, and so our cosine of 0 degrees is 1. Actually, I need to take out a degrees there. 0 in length, or in height, rather. So 0 is for sine, and cosine is 1. Now, tangent, again, is the opposite, the sine divided by adjacent, the cosine. So what is 0 divided by 1? Well, it's 0. All right, 30 degrees. So now we have our 30, 60, 90 right triangle. So our reference angle here is 30 degrees. And so think of our 30, 60, 90 special right triangles. If this is 1, the short side from the hypotenuse is half of that. To get back to the long side, we multiply that by the root of 3. So 3 root 2 is our long side, is our long leg, which is going to be our cosine on this one. So our sine here is 1/2. There's our opposite side from the reference angle. Our cosine, our adjacent side, is root 3 over 2. Our tangent is our sine divided by our cosine, so 1/2 divided by root 3 over 2. That's the same thing as taking the 1/2, and actually I'm going to rewrite this. The 1/2, we don't like to divide by fractions, so that's really 1/2 times the reciprocal here, so times 2 over the root of 3. 2's cancel out because 2 divided by 2 is 1, and we end up with 1 over root 3. Again, we don't like to have a radical in the denominator. We do what's called rationalizing, so multiply the top and the bottom by root 3, and we end up with root 3 over 3. That is our tangent of 30 degrees. All right, 45 degrees. So this is going to be a 45, 45, 90 right triangle. So our reference angle is now up to 45 degrees. 45 degrees this time. And for our special right triangles in that, if our radius is 1, this is going to be square root of 2 over 2 and square root of 2 over 2. They're equal. It's an isosceles right triangle. So our sine, that's our opposite side, is root 2 over 2. Our cosine is also root 2 over 2. And I'm not going to get too much into the math, but hey, if I divide anything by itself, even if it's something kind of ugly like root 2 over 2, but root 2 over 2 divided by root 2 over 2 is 1. Anything divided by itself is 1. All right, 60 degrees. 60 degrees really is this same triangle we talked about here, just now we're looking at it from a little bit different perspective with our reference angle being the 60-degree angle rather than the 30. So our cosine is the short leg, it's half of 1, so 1/2. And our long leg is times the square root of 3, so square root of 3 over 2. Sine is the y value, so root 3 over 2. Cosine is our x value, 1/2. And when we divide this out, we've got the square root of 3 divided by 2 divided by 1/2, which really is times 2, 2 over 1. 2 divided by 2 is 1, and it leaves us with the square root of 3 over 1, which is just the square root of 3. All right, last few ones. And again, once we know this part of the table and we know it very well, then we'll be okay, because now I'm just thinking about, oh, hey, once I've got a negative, remember that over here, so all students take calculus, that my sine is still positive in the second quadrant because the y values are still positive. My tangent is positive in the third quadrant because both the sine and the cosine are negative, and so a negative divided by negative gives to a positive. In the fourth quadrant, our cosine, our x value is positive, making our cosine positive. And then back in the first quadrant, all are positive. So we just apply those rules to the values we have here in the table. All right, and then lastly, let's just finish up 90, 180, and 270. So I think you already know these, and if not, then really you just need to go back and look at our notes from, I believe it was 7.3, and this part's laid out pretty well for you there. And now, but let's add in the pieces about tangent. So 1 divided by 0 gives us undefined. So there is no value for the tangent of 90 degrees. Okay? It's undefined. 180, that's 0 divided by -1. 0 divided by -1 is 0. And then 270, -1 divided by 0, again, can't divide by 0. This is undefined. Undefined. And keep that in mind, because that tangent graph is going to look very different than our sine and cosine, and we're getting there pretty soon. So I hope that helps.